Welcome everyone. Today what we're going to be discovering is how to graph exponential functions. It's a pretty long lesson, but it is pretty interesting, and you will learn from the ground up. On your own, you're going to figure out the formula we're going to use to graph these and how to go about the different parts. So by the end, you'll be able to graph the vertical movements of the exponentials, find out where their y-intercepts are, find out any horizontal asymptotes there may be, and then finally use 2 points to graph the exponentials along with what the domain and range are of the exponentials. All right, so we're going to use some previous work along with the work we're doing now in order to solve all these things. All right, so pretty easy things. Sorry about that. Just had to move my charger. So you are going to need your laptops for this, and we're going to start with the investigation. All right, now the reason I say we're going to need our laptops is we're going to graph a couple things and then discover from our graphs what the rules are. So our first investigation is we're going to consider the graphs of the exponential functions in the form y equals k a to the x power plus c, and also y equals k x to the negative a power plus c, where a is always greater than 0 and a is not equal to 1. Okay, now here's what we're going to do. We're going to do this in a couple sets. The first thing is, on the same set of axes, we're going to graph the functions y equals 2x, y equals 3x, y equals 10x, and y equals 1.3x. You're going to do that so you can figure out what the relationships between these are, and then we're going to be able to answer these questions from them. Now, in case you don't know how to do this, if you click to your online book, go to your online book, you're going to page 187, okay? It's C, lesson 8C, graphs of exponential functions, and the investigation's right here. And all you're going to do is, I'm going to zoom in a little bit so you can see, here's the investigation that we're doing. We're just going to click on the graphing package. And when we click on the graphing package, what we're left with is our graphs, and we're going to be able to graph our things here. If you want to use Desmos, you can use Desmos. If you want to use a graphing calculator, you can use that as well. But the book gives us this nice graphing package, so why not use it? So the first thing is y equals 2 to the x. So what you do is you type in y equals 2, the caret button, which is shift 6, x, and then you're going to hit enter. Now when you do this, this isn't center, so I can just click on my arrow, drag it down a little bit, get a nicer graph. Okay, so there's my graph of y equals 2 to the x in blue. The next one is y equals 3 to the x. So I go back up here, and I'm just going to change this. I'm going to go back, delete to y equals 3, caret x, 3 to the x, and hit enter. Notice this is where everything's going. And now my red graph is y equals 3 to the x. And in case you're wondering, I'm putting everything in this top right column. All right, the next one it says to do is y equals 10 to the x. 10 caret x. Enter. All right, so we go back down and zoom out so you can see. Oops, used the wrong zoom. Got my zooms all messed up. All right, so I'm right there. All right. Notice it's a little different there as well. Okay. Now I'm using Control V, Control Z to do this. Uh-oh. I messed mine up, so I'm just going to go out and go back in real quick. Sorry about that. There we go. I got y equals 2x. Enter. I try to get fancy and messed everything up. Get back in there a little more. Okay, y equals 2x. Y equals 3x, y equals 10x, and the last one is y equals 1.3x. Okay, now you have your pictures, you have what's going on here on the right hand side, right? So what relationship do you see between these? Okay, so what we're looking at is we want to find out the relationship. So now we're going to answer some questions. Okay, we plotted all our points here, we got all our graphs here. So I'm just going to flip back to the PowerPoint so I can do this a little easier. So on the graph we have y equals 2x, y equals 3x, y equals 10x, and then y equals 1.3x went out to the side. All right, so this is just a little basic sketch of what it looks like. All right, so is this function increasing or decreasing? Is it going up from left to right or down? Well, in all these cases it is increasing. All right, is there a horizontal asymptote? Is there a place where this graph is never crossing? No matter what number this is there something it doesn't cross? There is. What would you say it is? Y equals 0, because as x approaches negative infinity, y approaches 0, from the positive side. What effect does changing the A have on the graph? So what effect do you notice it has on the graph? Do you notice anything? Let's see. How about we do this? As A increases, whoops, what's happening to the graph? Does the shape change at all? It does, right? Y equals 0, sorry. As it changes, right, A affects how steeply the graph is going to be either increasing or decreasing. So depending on A. So pretty much increasing A, making A a higher value, makes the graph steeper. Makes it go, like have a sharper turn. Decreasing A flattens out your graph a little bit. It makes it increase less steeply. So it almost becomes like a straight line. All right, the closer you get to 0 as a graph. Or the closer you get to 1, because you're just doing values over 1. All right, pretty simple, right? All right, you guys ready to do? So we just figured out one thing. Let's go find some more stuff. So 2A. On the same set of axes, now you're going to graph 1/2, 1/3, 1/5, and 1/10. Once again, you can use your computer. Now remember, when you have your computer like this, if you click on these things, I'm just going to do this. Remove all. Right here, bottom left, hit remove all, and it will remove all the graphs. Okay? And now when you go to plot your new graphs, you should be done. In case you're wondering though, y equals, the key here is, when you're doing 1/2, you want to put the 1/2 in parentheses. 1/2, close parentheses, up arrow x. Okay? So that's my 1/2 to the x power. So why don't you guys type in the rest? You're going to do 1/3, 1/5, and 1/10. I'm just going to change the number here. 1/3, 1/5, 10. So your graph should look something like this. If I go over here, 1/2, 1/3, 1/5, 1/10. Okay? Now A is going to be between 0 and 1. So that's why it's all fractions. None of the fractions are negative. All right? None of the fractions have a higher number on numerator than denominator, because they're all less than 1. From left to right, the function is obviously decreasing. The horizontal asymptote, once again, as you approach infinity, you're approaching 0 from the positive side, so it's y equals 0. What effect does changing the A have on the graph? The same effect as before, right? So here's your horizontal asymptote. Gotta put that there. A affects how steeply the graph increases or decreases, once again. All right, and guess what? Increasing A, once again, now makes the graph less steeply. Okay, so as you increase A, right, 2 is the highest A, that's what flattens out the curve. So from 0 to 1, the closer you get to 0, the steeper the graph is, okay? As soon as you reach over 1 and you increase, it flattens. It makes the graph steeper. So it's like the opposite, okay? So in this case, increasing A kind of flattens out the graph. After you go over to 1, increasing A steepens your graph. Look at that. You just figured out 2 rules just by plotting in some points. All right? This is why I like the investigations. Now what you can do is, you can do the next one. 2 to the x, 2 to the x plus 1, 2 to the x minus 2. Now what we're going to do is we're going to figure out what the pieces are. So I go here, y equals, we'll start with 2, oops, sorry, let me remove everything. Y equals 2 to the x. All right, then right here, 2 to the x plus 1. 2 to the x plus, oops, sorry, minus 2. All right, so those should be the graphs that you have. Notice the intercepts are the key parts. All right, so the first piece, what happens is you got y equals 2 to the x. Okay, notice it goes through, and the key here is it goes through 1. All right, in the y-axis. The next one, y equals 2x plus 1. Now it goes through 2, so you should be noticing something going on here. All right, now we have original 2 to the x, and what you're going to do now is, it's 2 to the x minus 2. All right, well that one goes through negative 1. All right, so you should be like, interesting. There should be some type of pattern going on here. Can I figure out this pattern? Can you figure out the pattern? Let's check it out. What effect does C have on the position of the graph? C controls the vertical position. So C shifts it up and down. Now it's not necessarily the y-intercept, because 2 to the x, the y-intercept is 1, it's not 0. So C, what effects is that on the shape of the graph? Does that have any effect on the shape? No effect whatsoever on the shape. And you can see that better with this graph right here, because you can see these are all the same shapes. Like I can actually take this, pull this up, push this down, it'll all be the same graph. It's a little more difficult to see in this situation here. All right, so there you got that, a little bit there. All right, is there a horizontal asymptote? Well, what happens? It actually changes. All right, so whatever the C is actually a horizontal asymptote. Because look at this one right here, horizontal asymptote is 0. This one right here, so as 2x approaches 0, x approaches 2 from the positive side, so the C is going to be C from the positive. So you can approach your asymptote from the top, and it's going to be whatever C is. All right, so the horizontal asymptote is y equals C. So in this case it's 0, in this case it's 1, in this case it's -2. All right, and if you're having trouble figuring that out, if you look here, you can see here's about 1. Okay, here's 1. That's 1. Okay, 1. This is 0. Look at 0. Look at this one, 2, -2. Guess what? -2. All right, so that's how you do that. All right, now I just messed up my board. All right, another part of the investigation. Now we're going to do this. On the same set of axes, graph these two functions. 2 to the x and 2 to the negative x. So what that means is 2 to the x, 2 to the negative x. Now I already have 2 to the x, so I can just click on these and hit remove. I want to remove the green, remove that one. Okay, and then I want 2 to the negative x, so 2 caret negative x. And I get that. What do you notice is going on here? All right, interesting, right? So if I go here, I'm sketching them. They both go through 1, and they go in opposite directions. All right, I'm not going to go back to that for this next one. What about 5 and 5 to the negative x? Why don't you graph both then? All right, once again, oops. Messed that up. All right, I'm going to use this one. So 5 to the negative x. I'm going to erase these two. Remove all. So now I've got 5 to the x. All right, and 5 to the negative x. What do you notice? Still goes through 1, right? Interesting. That's weird. Okay. Still goes through 1, and they face opposite directions. This graph is correct. This should just say 5, though. I just wrote the wrong number. All right. Man, I checked these, I triple checked these too before I give these lessons. Still mess them up. All right. Next one, 1/3. All right. They just go in opposite directions. Okay. If you want to type it in here, just put 1/3 in parentheses. All right. I'm going to do one for you. Open parentheses, 1 divided by 3, close parentheses, up arrow x. Okay, and do the same thing to the negative x. Notice once again, it passes through 1. It's just a little flatter. Okay. So that's some interesting stuff, isn't it? Now what exactly does that tell us? Does that tell us anything? Should. All right, so what is the y-intercept for each graph? You already said it. It was what? It was 1. When x equals 0, so for instance, when a to the 0, x equals 1. All right, so y to the negative 0, y to the negative power, also equals 1. Okay, so a to the x, when x is 0, the intercept, it's always going to be 1. Okay, so the y-intercept for every graph is going to be y equals 1. Y-intercept these graphs, y equals 1, not 0, 1. Alright? Now the horizontal asymptotes of each graph. Well, that's interesting. What do you got for that? We need to go back real quick. What is the horizontal asymptote for each graph? Well, the y-intercepts are all 1. Horizontal asymptotes are all, what? 0. For any time a is greater than 1, as x approaches infinity, a to the negative x is approaching 0 from the top. Okay, as x is approaching negative infinity that way, a to the x, it's also from the top. When we have a fraction, like we did with the thirds, right? As x approaches negative infinity, or as x approaches, when x is to the negative x is approaching 0 from the top. As x approaches positive infinity, when y is a to the x, is also approaching from the top. All that means is that if I have a graph right here, right, as I'm approaching negative infinity, it's approaching 0 plus. 0 plus means 0 from the top. As I'm approaching positive infinity, it means it's approaching 0 from the top, right? And then this right here is always going to be 1. Horizontal asymptote of each graph, y equals 0. Describes how the graphs of y equals a to the x and y equals a to the x are related. Well, we just said it. How are the two graphs related? Let's look at this one right here. Red and the blue. How are they related? They are a blank of each other. Because of an R. A reflection of... Oh, did I already put it down there? Ah, it's a reflection. And it's reflecting over the y-axis. So it's a reflection over the vertical axis. So if I have a line of reflection right here, whatever you do to the left, do to the right, and vice versa. Okay. So another piece of the investigation puzzle, down. All right, one more thing to do with the investigation. Actually, 2 more slides. Oops, where are we at? All right. So explain why y equals a to the negative x and 1 over a to the x for all x a's that are greater than 0, so this can't be negative, and a can't be 1 because if a is 1, it's just the same thing. So why are they equal? How are these two graphs related? A to the negative x and 1 over a to the x. Well, look at a to the negative x. This is just a matter of math. They're both the same thing. A to the negative x is the same as a to the negative 1 times x. Okay, and you guys should know from your power rule, if you have x to the a times x to the b, right? That's x to the a plus b. But this isn't multiplying. This is a power to a power. X to the a all to the b power equals x to the a times b. This is just exponents rules. So negative 1 times x is a to the negative x. So you're pretty much doing power to a power. This rule right here. A lot of people get these confused. And that's the same as another rule is x to the negative a equals 1 over x to the a. Or 1 over x to the a equals x to the negative a. And that's what you're doing here. 1 over a, this is 1 to the x, a to the x. So you're using another rule. X, and this is a tricky one. X to the a over, I'm just going to make another letter, y to the b, all to the c. You would raise both of these to the power. This would be x to the a times c over y, b times c. So you'd raise both of these to the power. 1 to the x is 1, a to the x is a to the x. Okay, and that's when a is greater than 0 and a is not equal to 1. So 1 over a is another way to write it. 1 over a to the x, using this rule right here. 1 to the x, a to the x, using this rule. This one uses this rule. All right, so 1 to any power is 1 over a to the x. And then what we said right here, using this rule right here, a to the negative x. And that's how you prove they're equal. All right, it's pretty easy. Since a to the negative x, for all the times that a is greater than 0 and a is not equal to 1, the graphs are therefore identical. So all you do is a little mathematical manipulation there to figure that out. Will we need to know that? Not necessarily, just because as long as you know the rule, you're good. Right? But let's going to figure out all the rules we're going to use. So we're going to use all these rules to graph. So first one, for the general expression, ka to the x plus c and y equals ka to the negative x plus c, what controls the vertical position of the graph? Which letter? C. Whenever C is, that controls where your graph is. Horizontal asymptote. What is the horizontal asymptote in all of these cases? Y equals C. Whatever C is, that's what my horizontal asymptote is. This also controls the horizontal position. It's the vertical position. So two things. A and K. A and K show how steeply the graph blanks or blanks. Increases or decreases. Okay, so depending on if you're between 0 and 1 or higher than 1, that depends on that. And then finally, the sign of K determines whether the graph lies above or below the asymptote. Okay, positive above, negative below. Now we can sketch this using all these things. All we need to do is we need to find the horizontal asymptote. We need to know where the y-intercept is, and two other points. And if we do that, we can sketch exponential functions all the time. Because all exponential graphs have a horizontal asymptote. And once again, we're going to use C to figure out that horizontal asymptote, and then we're going to use the other letters to figure out things as well. All right, you ready? That was all a big setup. That was the whole setup. We didn't even start the lesson yet. Here's the start of the lesson. Now, what we're going to do is we're going to look at example number 2. All right. So we're going to sketch the graph of y equals 2 to the negative x minus 3. And then we're going to state the domain and range of that graph. Now here's the thing. I want you're allowed to use your graphing calculator to check your answer, but let's try to sketch it first without any help. All right, it's always good to just try things first, and then after we try it, then we're going to see if we're good. All right, so first off, how many graphs are there? 3, right? Okay, so we're going to find the horizontal asymptote, and then we're going to find 3 points. So, what's the horizontal asymptote here? -3. Why? The horizontal asymptote is always this. C equals -3. So at -3, we have a horizontal asymptote. Boom. Put it right in a graph. Easy enough, right? Whatever this is, that's what it is. Right? When x equals 0, now we're going to find a couple points. So x equals 0 is going to be, this is our y-intercept, right? So what do? Plug 0 into the equation and solve for f of x. Okay? 2 times -0 minus 3. Anything to the 0 power is 1. So this is y equals, -0 is the same as 0. So that becomes 1 minus 3. Okay? I did the extra step there. You didn't really need to do it. All right? 1 minus 3. And 1 minus 3 is -2. So -2 is going to be my what then? What's -2? That's my y-intercept. So put your y-intercept at -2. That's point -0, -2. Boom. You all good? All right. So now we got our y-intercept. Now what we're going to do is continue on. Now what are we going to do? We got our y-intercept. When x is 2, we're going to find 2 points. Always good to find one on each side of the asymptote. Each side of the intercept. So plug 2 in there. 2 to the -2 minus 3. All right. 2 to the -2 is 1 over 2 squared, which is 1/4 minus 3. 1/4 minus 3 is 1/4 minus 12 over 4, which is -2 and 3/4. Or negative, -11 over 4. Right. Put your point. -2 and 3/4, 2. next one. Plug it in, solve. Alright. 2, negative 2 to the second power is 2 squared. 2 squared is 4 minus 3. 4 minus 3 is 1. So our next point is negative 2, 1. Plot that point. Step 3. Draw a curve that goes through that. Now, here's the deal. This is our horizontal asymptote, so your curve is not going to go through here. It's going to come here and it's going to run very close to here, and then it's just going to move up. And there you go. Never crosses this line, so just flatten it out here, and then just shoot it up over there. It's a sketch, so it doesn't have to be exact. Domain. What's the domain? Domain, remember, is the x values, okay, left to right. So let's see, this goes to which way? Negative infinity this way, goes to infinity this way, right? That's our domain. So our domain is all real numbers. Okay, remember, it's x, the set of x's, x is the set of all real numbers. Now what's our range? A little trickier. Now our range right here, we're going to go up to infinity, right? So that's our highest one. But we go here. Now we don't hit this point, so we go from this point up to infinity. Now what's this point? Negative 3. Now it doesn't include negative 3, but it's every value greater than negative 3. So it's every value greater than negative 3. That's it. So the range is all the values of y, where y is greater than negative 3. If it was under the graph, it would be less than negative 3. Okay, in no cases is your range for an exponential function going to be y is greater than or equal to or less than or equal to, because you always have this asymptote here, and it never actually touches that asymptote. Right? Boom. All right. We're going to get back to that. So we're going to start with an easy question, number 1. Actually, 1, 2. We're going to start with a bunch of easy questions. Oh man. So number 1, first question: match the function to the graph. Go. You're going to have to use each piece of each function to do this because there's no real numbers here. So I'm going to give you some hints. Figure out which ones go up, which ones go down, right? Which ones go to the right, which ones go up. And then you're going to have to figure out here which one is steeper and which one is flatter. All right. I think I gave you enough time. So the first one, we're going to start saying, and you can do this in any order. This is just the order I went in. Both 2 to the x and 10 to the x have a k that's greater than 0, right? And an a that's greater than 1. All right, so that means they're both positive, and it means both these numbers are not fractions. Okay, so that means they both go up and they both go in the same direction. So that means it can either be B or C, right? So both graphs lie above the horizontal line, right? And they're increasing. All right, they're increasing because they're positive. So that's B or C. Now you have to figure out, one of them is A, B, one of them is C. Remember, as you increase your value, it gets steeper when you're above 1. So 10 to the x is steeper than 2 to the x because 10 is greater than 2. So which one's steeper? B. So that means that 2 to the x has to be C, and 10 to the x has to be B. All right? You're just using your knowledge right here. Next one. All right, so let's see this one. Negative 5 to the x. Well, negative 5 to the x has a k that's less than 0. It's negative. But also, a is greater than 1. So it's not a fraction. It is a whole number. Because of this, okay, because a is greater than 1, it has to be above, the graph lies below the horizontal asymptote. Okay? Below, because it's negative, right? All negative numbers are below the asymptote. Okay? And it's 5, okay? Negative 5, right? It's decreasing. Horizontal asymptote is 0. So which one do you think it is? D or E? D. Because it's decreasing. Okay? The reason it's decreasing is because it's negative, and this number is greater than 1. Okay, it's pretty much a reflection of these ones up here. All right, now D and E are both fractions. Now 1/3 to the x has k, which is, k which is greater than 0, meaning it's positive, and it's between 0 and -1. So because it's positive, it's above the horizontal asymptote, and because it's a fraction, it's decreasing. Okay, and there's only one choice to do that, and that one is exactly A. And the last one, -1/2, has k, which is less than 0 because it's negative, and the A is between 0 and 1 because it's a fraction. So because it's negative, it is below the asymptote, y = 0, and because it's a fraction, it is increasing. Only choice there is D. Okay, because it's a fraction below. So you're just putting in all your rules together and solving for them. Now, do you have to write out all these explanations? Of course not. I just do that so you guys can see what is going on. Next one, sketch the pair of functions on the same set of axes. So I want you guys to do this. Now you can go, okay, 2 to the x, 2 to the x plus 3. You can go here if you want. You know what? I don't know what it is, so I'm going to type in 2 to the x. Nope, I gotta get rid of these guys first. Remove. And then 2 to the x plus 3. So you do yours real quick. Oh, look at that. So on my sketch, here's how you figure out your sketch, your horizontal asymptote. Okay, good. Crosses through 1. Horizontal asymptote at 3. Crosses through 4. So now I can do my sketch. So my sketch crosses through 1. Horizontal asymptote at 0. This one crosses through 3. And my horizontal asymptote, crosses through 1 plus 3 is 4. My horizontal asymptote is 3. Why? Whatever this is, that's where my horizontal asymptote is. One above there. All right, remember, horizontal asymptote. All right, do B, C, and D. I'm not going to go back to the computer. I'm just going to do the answers. All right, B, 2 to the x, as usual, crosses through 1. Because this is a negative x, it reflects across the y-axis, so it should be going the other way, also through 1. Both horizontal asymptotes are y = 0. All right, C, 2 to the x, 5 to the x. Well, we know they're both going to go through 1. We know they're both going to go in the same direction. They should be doing what? Increasing, right? So they go through 1, and it's increasing, has a horizontal asymptote of 0. But because this is 5, is it going to be steeper or flatter? It's actually going to be steeper. I'm not sure. Oh, look at this one as a scalar. 2 times 2 to the x. So 2 to the x by now we know increases, crosses through 1. So what do you think happens if it's 2 times 2 to the x? Well, it's 2 times as big, right? So if this is the same as putting, this makes it larger. So larger number in front because this is greater than 1. It's going to be steeper. But now it's going to go through 2. Why? Well, you're going to find out in a second. All right? Because what you're doing is you're taking every point on here and you're multiplying it by 2. So at this point, this x value is, this value of this is 1. The value of this is 2. If the y value of this is 2, the y value is 4. The y value of this is 8, 16. So it's going to get wider and wider the higher you go up. Because you're doing twice the y value. Right. That's a pretty cool one, right? All right, 3, sketch the functions. More sketching. Now we're just going to do a bunch of sketches. All right. Let's go through the answers here. 3 to the x, once again, goes through 1. Flattens out here. Negative x. There we go. It's just a mirror across the y = 0. Or x = 0. Asymptote or y-axis. Adding 1. So the first one, 3 to the x, goes through here, goes through 1. If you're adding 1, you're going to take this, you're going to slide it up 1, and my horizontal asymptote goes from y = 0 to y = 1. Should be able to pop these guys out quick. 3 to the x negative, wait a second, oh, this is a little different? Tricked me. 3 to the x is the same. Now this one says negative 3 to the x, not 3 to the negative x. So you're switching it up. So instead of switching the directions over here, when you make the actual k in front negative as opposed to the variable, you reflect over the x-axis. All right? So when you make the thing you're raising to negative, reflect over the y-axis. When you make the whole problem negative, reflect over the x-axis. Right? Now, 3 to the x. 1/2 3 to the x means I take all these values that are y's and I half them. So my graph is going to be a little bit smaller. So 1 goes to a half there. Okay? If this one says like 8, if this was like y equals 8, this would be y equals 4. It's just whatever your f of x values are, you have half. Alright? Because that thing out front is known as a scalar or a multiplier. I don't know why they call them multipliers, but that's what they like to do in IB. Alright. Next step. State the equation of the horizontal asymptote of y, a to the x plus c is the rule we're going to use. So we're going to use that to find the horizontal asymptote. Right? Because remember, y equals c is going to be your horizontal asymptote. So you should be able to finish these 4 problems within seconds. Alright? What's horizontal asymptote here? Right there. -1. Nothing to. Ready? Next one. What's the horizontal asymptote? Y equals 4. Alright? This one. You got a bunch of stuff going on here, but remember this is the multiplier. It's whatever you're adding and subtracting. So it's that 1. Boom. Y equals 1. -5. Right? Good job. Number 5, find the y-intercept. Do you, ladies and gentlemen, remember how to find the y-intercept? In order to find the y-intercept, what equals 0? It's when x equals 0. All right? So when x equals 0, just find f of 0, right? So f of 0 equals 3 to the 0 power plus 1. Anything to the 0 power is 1. That's x equals 4, sorry. 1 plus 4, 5. So my y-intercept is y equals 5. We're going to use all this information in a second. We're going to put it together to solve more difficult problems. F of 0 equals 6 to the -0. -0 is just 0. 6 to the 0 is 1. -2 is -1. Y equals -1 is my y-intercept. C. 3 times 2 to the 0 plus 7. 3 times 1 plus 7. You have to use PEMDAS. So parentheses, exponents, and then multiplication. 3 times 1 is 3. And then addition. 10. Y equals 10 is my y-intercept. -1/2 times 5 to the 0 plus 6. -1/2 times 1 plus 6. -1/2 plus 6 is 5.5. Or 11/5. Or 5.5. So y equals 5.5, 5.5, 11/5, 11/2, sorry, would all be types of your y-intercept. Right. Now, we're going to up our game. Problem 6. Consider the exponential function. F of x equals 3 to the x minus 2. You're going to find f of 0, f of 2, and f of -2. So what that means is you're going to take these 3 numbers and you're going to plug them in for x in your problem. Go. Like I said, this is still pretty easy. Okay, A. F of 0 is 3 to the 0 minus 2. 1 minus 2 is -1. This is actually your y-intercept. F of 2. You didn't know that, did you? 3 squared minus 2 is 9 minus 2, which is 7. 3 to the -2 is 1 over 3 squared, which is 1 over 9 minus 2, which is -1 and 8/9, or -17 over 9. Both are okay. All right. Now, look at that equation. what is my horizontal asymptote? I'm sorry, or negative 189. There we go. Horizontal asymptote is y equals negative 2. Why? Because this is my horizontal asymptote. Now, can we sketch a graph using 1, 2, 3 points and my horizontal asymptote? Of course you can. Sketch the graph. All right, let's see. Here's the graph. Wait a second. Is that right? Well, here's the graph of y equals 3 to the x. But we're going to use one with a y equals negative 2. Okay, that's our horizontal. We have points 0, negative 1. My y-intercept, that's from here. That's where that negative 1 comes from. We have points 2 over 7 up. And we have points negative 2, really close to 0. Set the domain and range. Domain is your left to right value. Domain is always going to be all real numbers. For every exponential function, your domain is always going to be all real numbers. Your range, our range is going to start here and everything up. So everything above negative 2. So that is all the values of y where y is greater than negative 2. Right? So we did a crude example, and now we're going to get into the more advanced examples. All right, so I want to do problem 7, which is very similar to this. Boom. All right, should be done. Now, I know I'm moving a little quick here, but I am pausing and going as you go. So find g of 0. 3 times 1/2 to the 0 power. 3 times 1 plus 4 is 3 plus 4, which is 7. So 0, 7, you can put it right here. Now 0, 7 is your intercept. G of 2. 3 times 1/2 squared. 1/2 squared is 1/4. So 3 times a fourth plus 4 is 3/4 plus 4 is 4 3/4. Negative 2. 3 times 1/2 to the negative 2 plus 4. Now, because this is negative, I invert it, so it's 3 times 2 squared, which is 4. 3 times 4 is 12. 12 plus 4 is 16. All right, sketch the graph. All right, what's the horizontal asymptote? Right there. So y equals 4. Sketch the graph. I'm going to put my the original graph. 3 times 1 to the x. Looks kind of like this. What we could do with this, we know y equals 4. And you don't have to put the blue. That's just to help you guide you through. Y equals 4 is my horizontal asymptote. All right. I know I have a point at 7. Right here, because that's my y-intercept. I know I have 2 over and about 4 3/4, so I'm getting really close to 4. I know I have a point negative 2, 16. Right? So that's what my graph looks like. This is what it looks like before your shift and then after your shift. Okay. And it doesn't look like it, but all these are the same units away. Because once you get here, you can't really tell because it's going up like that. But notice these are all the same units away. I know it doesn't look like it here because it looks a little squunched, but it really is. All right, domain, all real numbers. And your range is every value greater than 4. Okay. Want to go more advanced? Nice. Let's go. For the following exponential function, calculate the y-intercept. Now we're going to do real problems. So calculate the y-intercept. All right, you should have done that by now. How do you find the y-intercept? You set x equal to 0. So when x equals 0, that's when you find your y-intercept. Y equals 2 to the 0 plus 1. 1 plus 1 is 2. So y equals 2 is my y-intercept. That's easy enough, right? State the equation of the horizontal asymptote. So let's look at our problem. Right there, horizontal asymptote is y equals 1. First two things are very easy. Step 3. Find the y values, okay, if x is given those things. So now we're graphing this with 2 points. So the first point right here is with 2. So we take 2 and we plug it in. 2 to the second power plus 1. 2 squared is 4. 4 plus 1 is 5. So our point's going to be 2, 5. Next one, negative 2. 2 to the negative 2 is 1 over 2 squared, which is 1 over 4 plus 1, which is 5 over 4, or 1 1/4. okay? Either one is okay. It doesn't matter, you can say 1.25, that makes you happy. So now we got this, and we got our 2 points. We're gonna sketch our quadratic. Number 1, plot your y-intercept. So you go, put point 2, right? It's sketching, so there is no numbers here. You're just drawing what you think it's about. These may be a little different. Y equals 1 is my horizontal. So here's what you want to do. This, since you're sketching, just has to be halfway between 0 and 2. That's a sketch. All right? So now we got 2 pieces. We're going to plot these points. 2, 5. That's what this means. When x is 2, y is 5. So that means this point is 2, 5. I'm not going to do this again, but I'm just showing you. So I plot a point over 2, 5. When x is negative 2, y is that. So this is negative 2, 5 fourths. All right? Negative 2, 5 fourths. And now all you're going to do is you're going to say, okay, this is good. I can see this graph is definitely increasing. I know it's going to hug this, so it's going to be kind of flat here. And then just pick up and go up. And there's my graph. State the domain. Well, we said it's all real numbers for your x. And for your y values, it's every value above 1. So y is greater than 1. Right? So that's not too bad. Now we're going to do a bunch of these. So keep on working on it. So you're going to start with that one you did good. Now go to the next one. Go to B. All right. Y-intercept, you said x equal to 0. When x equals 0, 3 to the negative 0 is 3 to the 0 is 1. 1 plus 4 is 5. Y equals 5 is my y-intercept. If you want to plug it on here now, you can. You don't have to. Horizontal asymptote. I see. It's 4. Y equals 4. All right. Plug in the 2 values for 2 and negative 2. 3 to the negative 2 plus 4 is 1 over 3 squared, or 1/9 plus 4. 1/9 plus 4 is, this could be 4 and a 9th if you want, or you can transfer 4 into 36 over 9. I multiplied 4. I wanted a 9 on the bottom to match here, so I multiplied that by 9 too, which gives you 37 over 9. If you prefer just to put 4 and 1/9, you can. It doesn't matter either. When x is negative 2, negative 2 is squared, so 3 squared is 9. 9 plus 4 is 13. So now our first point, 5, 0. Y equals 4, just a little bit under there. This point, 2 over and a little more than 9 up. So what I do is I go 2 over and a little more than 9 up. Oops, sorry. Wait, a little more than 4 up, sorry. This is 4 and a 9. All right, so it's 2, 37 over 9, or 2, 4 and a 9. This one, negative 2, 13, so negative 2, about 13 up. This tells us I can connect my graph. There we go. State the domain, all real numbers for x. For range, anything, there you go, above 4. Y is greater than. All right, for C. For C. We got a bunch of these to do. All right, so calculate the y-intercept. X is 0, y equals 1. Y equals 1 is your y-intercept. Horizontal equation. Now there's no C, therefore it's 0. Find the values of y when x equals 2 or when x equals negative 2. When x equals 2, 2 over 5 squared. 2 squared is 4, 5 squared is 25. So, the answer is 4 over 25. Negative 2. All right, because this is negative, you inverse this. So instead of being 2 squared over 5 squared, it's 5 squared over 2 squared, because you're doing both of these to the negative 2. All right, so what you do is you just pretty much inverse this, and 5 squared is 25, over 2 squared is 4. Got it? Let's plot. Y equals 1. Y equals 0. Interesting. 2 and 4, 25. 2, and right here, I already have an idea of what's going to go on. Negative 2, and what's that? About 8 1/4. Whoop, about up there. All real numbers, y is greater than 0. Right. Well done. All right, D. Sorry for the long yawn. Long day. All right. Set x equal to 0. 1/2 to the 0 power is 1. 1 minus 3 is -2. Y equals -2 is your y-intercept. State the equation of your horizontal asymptote. Whoop, there we got another one. -3. So y equals -3 is your horizontal asymptote. Right now, by just using these two, you can pretty much figure out what your graph's going to look like. But it's just always good to take your 2 points. When x equals 2, 1/2 squared minus 3. 1 squared is 1, 2 squared is 4, so it's 1/4 minus 3, or 1/4 minus 12 over 4, which is -11 over 4. Now, if you don't like using -11 over 4, you can also just say negative, what's this? 2 3/4. Okay? That makes you happier. When x equals -2, 1/2 to the -2, remember you inverse the fraction, so it's 2 squared over 1 squared, right? Which is 4 over 1, minus 3. 4 minus 3 is 1. -2, -3, 2, -2 3/4, -2, 1. All real numbers, greater than -3. Your range is always going to be y is either greater than or less than whatever number that is. All right. What's that? D. Let's move on to E. Now it's 2 minus 2 over x, to the x. All right, calculate the y-intercept. Set x equals 0. 2 minus 2 to the 0 power, 2 minus 1 is 1. So y equals 1 is indeed your y-intercept. Horizontal asymptote? No, that is an x attached to it. What is it? It's the number that's by itself. 2. So y equals 2. When you're plugging in 2, 2 minus 2 squared, 2 minus 4 is -2. So 2 -2 is our first point. -2, okay? 2 to the -2 is 2 minus 1 over 2 squared, or 2 minus 1/4. Okay, 2 minus 1 over 2 squared. 8 over 4 minus 1 over 4 is 7 over 4. Or if you like it better, you could do 1 3/4. Either one's okay. Y equals 1. Y equals 2. All right, let's plot our points. 2, -2, 2 over, 2 down. -2, 7/4. All right. I can see the graph now. Looks like that. Domain, all real numbers for x, and range is going to be all the values. Y is less than 2. Okay. Under, y is less than the asymptote. Above, y is greater than the asymptote. I'm actually happy with how this is going so far. All right. F. Calculate the y-intercept. And x equals 0. 4 to the -0 is 1. 1 plus 3 is 4. Y equals 4 is your y-intercept. State the equation of the horizontal asymptote. 3. Y equals 3 is our horizontal asymptote. Right. Find the values of y when x is 2 and y is -2. All right. 4 to the -2 plus 3 is 1 over 4 squared, or 1/16 plus 3. If you want, you can do 1/16 plus 16 over 16 times 3 is 48 over 16. 49 over 16. Or you can just say 3 and 1/16. When x equals -2. 4 to the -2 is 4 squared plus 3. 4 squared is 16 plus 3 is 19. All right, now we're going to graph our stuff. y equals 4 is our point. Whoop. Y equals 3 is our horizontal asymptote. All right, when x is 2, you got about 3 1/16, so it's just barely above the line. When x is negative 2, you're all the way up here at 19. Your graph is decreasing from left to right. Above the asymptote, domain is all real numbers, range is everything. Y is greater than 3. Two more of these. Calculate the y-intercept. When x is 0, 3 minus 2 to the negative 0. 3 minus 1 is 2. So y equals 2 is my y-intercept. Horizontal asymptote is in front again, so it's 3, y equals 3. The values, x is 2, 3 minus 2 to the negative 2. Okay, 3 minus 1 over 2 squared, 3 minus 1/4 is 12 over 4 minus 1 over 4 is 11 over 4. All right, you could also say, as we did before with this one, I think, 2 3/4. This one looks familiar. Next one, y equals negative 2, 3 minus negative 2. All right. 3 minus 2 squared. 3 minus 4 is negative 1. All right. Plot our points. Y equals 2. Y equals 3. Okay, 2 3/4. So 2 3/4 is here. Negative 2, negative 1 is down here. Okay, I always go to see which one's closer to here, and I go this one. And there's my answer. Right? Cool. Domain, x is all real numbers, y is less than 3. You may be saying, why is we have all these 3s and 2s? I just tried to, or the book just tried to keep the numbers small, so it's a little easier for you guys to sketch. That's one of these. Oh, we got a multiplier. Calculate the y-intercept, same thing. Set x equal to 0. Negative 1/2 times 1 plus 1. Negative 1/2 plus 1 is 1/2. Y equals 1/2 is our y-intercept. Horizontal equation, not this, not this, not that. It's whatever you're plusing or minusing, so y equals 1. Find the values when x equals 0 or x equals negative 2. Or x equals 2 or x equals negative 2. So when x equals 2, okay, negative 1/2 times 3 to the negative 2 plus 1. Negative 1/2 times 3 to the negative 2 is 1 over 3 squared is 1/9. 1 times 1 is 1. 2 times 9 is 18. So it's negative 1 over 18 plus 1 or plus 18 over 18. 17 over 18. Right? Just forgot my 1. Next one. Any questions yet? All right, you should be done with the next one too. The next is negative 2. Negative 1/2 times 3 to the negative 2. Negative 1/2 times 3 squared, which is 9. Negative 9 over 2 plus 1, so negative 9 over 2 plus 2 over 2 is negative 7/2. Also, negative 3 1/2. Okay? Plot our points. Y equals 1/2. Y equals 1. All right. 2, 17 over 18. 2, 17 over 18. Okay. Negative 2. Negative 3 1/2. There's a graph. The reason I put this arrow there is I didn't want to get mushed up there. Domain, all real numbers. Range, less than 1. Y is less than 1. Okay. All right, so now you guys can do this. We are done with the easy stuff. Now we're going to bring it up a level. Right? Get out those graphing calculators. You need those yellow calculators. Those good, old, yellow, fun calculators. These guys. Boom. In this example, y equals k to the 3x, all right, plus c, where k and c are constants. Find the value of k and c. What do you think? Easy or difficult? We are going to have to do one of your favorite things. I'll give you a hint. Systems of equations. So here's how it works. First thing you're going to do is create the first equation. You're going to substitute in 0, 2 into the equation. Y 0, 2. Well, this right here is your y-intercept, right? So it's just not 2. The point actually is 0, 2. You just don't put 0 because it's there. And that's point 1. And point 2 is 1, negative 2. So I want you guys to plug this into that equation. Now the 0, 2 is not your k or your c. What the 0, 2 is just your point. Got it? All right. Good? So what you should have done was 2, which is my y, equals k times 3 to the 0, which is your x, plus c. 2 equals k times 3 to the 0 plus c. 3 to the 0 power equals 1. So 2 equals 1 times k. 2 equals k plus c. All right, that's your first equation. So I want you to use that information now to find your next equation. All right, so y, negative 2 equals k times 3 to the 1 plus c. 3 to the first power is 3. Negative 2 equals 3k plus c. And you may say, what in the world do I need to worry about that for? Well, what we're going to do now is we're going to solve systems of equations. We have 2 equals k plus c, and we have negative 2 equals 3k plus c. Okay, and we're going to use that information to solve some stuff now. All right. How? Well, let's bring out our calculators. Oh, I hate doing this because I'm going to forget to unfuzz you. All right, so in our calculator, we go to our favorite old button, apps, right there, apps. We go down to number 9, PLY, SMLT2. We go to simultaneous equation solver, which is number 2. We have 2 equations, enter, and we have 2 unknowns, enter. Everything else looks good. Let me get over to next. Oh, then you hit the graph button, which is next. All right, this is the next button. All right, so let me go put this in. Remember, whatever's next to the x will just be my k, so I put 1k, all right, plus 1c equals 2. Okay, so that is k plus c equals 2. And then the next one, I got 3k plus 1c equals negative 2. Okay, instead of k and c, I just use x and y. It's the same thing. It's fine. Doesn't matter what the letters are. I hit solve. X equals negative 2, y equals 4. So k equals negative 2, and y equals 4 should be my answer. Let's go get that zoom back in on there. Good. Are we clear? We're clear. Boom. All right, very good. So let's see. Based on my graph right here, I typed everything in like I just showed you. And I got k equals negative 2. Awesome. And c equals 4, just like I told you. And there we go. So the graph is going to be y equals negative 2 times 3 to the x plus 4. Boom. And that's it. All right. Now I want you guys to do a problem. Go. from 9. This graph shows k times 2 to the x plus c, where k and c are constants. All right, what you're going to do is find the value of k and c. Go. Go, 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 go. You can do a couple of these, and then we'll move on. All right, so you should be doing it. Then you should be plugging it into your equation. When you're finished. All right, so first thing, you created your two equations. Okay, after creating your equations, what you should have is -5. 0, -5 is the first point you plug in because that's your y-intercept, right? And then after you plug that in, you should be able to solve. -5 equals k times 2 to the 0 plus c. 2 to the 0 is 1. -5 equals k plus c. Then you're going to substitute in 210. 10 equals k times 2 squared plus c. 2 squared is 4. 10 equals 4k plus c. All right? Now what you're going to do is you're going to use your simultaneous equation solver on your calculator. Okay, very simple to do. You're going to go to, once again, apps. Oops, I always got to clear out of this. Or go back to the main. Oops, clear, 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 clear. All right, so I'm back on my calculator. Oh, now I'm fuzzy again. It only works once for some reason. All right, so I go to apps. I just press number 9 to get down there quick. P less than y, and then I press 2. All right, 2 unknowns, 2 things. Next, I got all my stuff in there from last time, but that doesn't matter because I'm just going to go 1, 1, -5. All right, this one is 4, 1, 10. I hit solve. I get k equals 5 and y equals -10. K equals 5 and y equals -10. Let's see if I'm correct. I get k equals 5 and y equals -10. All right, so k equals 5, c equals -10. All right, nice and easy. All right, after I do that, my next step is to write my equation. My equation is y equals 5, which is my k, times 2 to the x minus 10, which is my c. All right? Now what I'm going to do next is I'm going to take my equation, all right, find y when x is 6. So I plug 6 in for x, and now I'm going to solve for y. Y equals 5 times 2 to the 6th power, minus 10. Y equals 5 times 2 to the 6th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 5 times 64 minus 10, 5 times 64 is 320, minus 10, y equals 310. And then you're done. There we go. So what we did was, we used some points on a graph to create an equation, because we knew the basic equation, we just didn't know the constants, and we used those constants, therefore, to find an unknown. All right? I think that's pretty impressive. What do you think? Yeah. All right, let's go to number 10. The graph shows the function f of x equals 3.5 minus a to the negative x, where a is a positive constant. The point, -1, 2, lies on this graph, okay? And that's all we know. So, we have to figure some stuff out. We're going to write down the coordinates of the y-intercept p. So we're going to have to try to find out what p is. All we know is that one of the points on this graph is -1, 2. Wait, that can't be right, because it doesn't look like that graph. All right, so what are you going to do? What are you going to do? What are you going to do? Oh, yeah, it does. Done. So we know one of these points is -1, 2. So this may be, I don't know, it may be, may not be. Right around there is -1, 2. We're trying to find P. So point P there is we don't know. So how do we find it? what's the first thing we're going to have to do? We want to find out what f of 0 equals, right? Because p is the same as f of 0, right? When x equals 0, right? That's what p is. So how do we find f of 0? It's 3.5 times a to the negative 0, 3.5 times a to the 0, which is just 3.5 minus 1, 2.5. Look at that. We were able to find it. The y-intercept is 2.5. Why? Because the y-intercept is always going to be...
Pardon, can I have a custodian bring a ream of paper to room 204, please?
It's always going to be...
All right, thank you.
Whatever your asymptote is, minus 1. Or plus 1. Depending on how you set this up. Alright? So now can we find the value of a? Because now we got our 2 points, right? So let's use our system of equations. So we know that f of 1 equals, so point P is 0, 2.5, right? We know our other point is negative 1, 2. So we can create a system of equations, kind of, right? We take negative 1, 2, we plug it into this equation. 3.5 minus a negative 1 times negative is a positive 1 equals 2. 3.5 minus a to the first power equals 2. You have k, so you don't have to use system of equations. Subtract 3.5 from both sides. Negative a equals negative 1.5 because a to the first is a. A equals 1.5. So just having 1 point, you only need 1 point to solve this as long as you have your k. What's the equation of the horizontal asymptote? Oh, we said this before. That was easy. Y equals 3.5 because it's right here. And if we wanted to do the actual, what's the equation of the graph? You could say f of x, and they didn't ask this, equals 3.5 minus a, which is 1.5 to the negative x. All right? And you're able to do this as a calculator because you already have your k. If you have one missing variable, you only need 1 point. 2 missing variables, you need 2 points. Oops, 2 points. If you have 3 missing variables, you need 3 points. And all you need is this, find your k. Number 11. Let's go back to the fun calculator stuff. All right? Almost done, almost done, almost done, almost done. All right? We got our answer almost? We're finding k, finding k, finding k. All right? Way this works, substitute in 0, 4 first. 4 equals k times 2 to the 0 plus c. 4 equals 2 to the 0 is 1. So 4 equals k plus c. Okay? 2, 7. 7 equals k times 2 squared plus c. 7 equals 4k plus c. Okay, so those are our 2 equations. What you're going to do now is you're going to take your calculator and plug both of those answers into your equations. So let's go, let's clear our memory, make sure this is, actually you don't even need to. Now what I'd like to do to save some time is, if I'm right here, see I still have my last problems plugged in here, I just hit main. I go main, see right here, y equals, and it brings me right here. Then I go right back into simultaneous equation solver, hit next, and I'm right here again. Nice and quick. Now I can go 1, 1, 4. All right, I'm solving this right now with you. And then 4, 1, 7. All right, so that's what I should end up with as an answer. 1, 1, 4, 4, 1, 7. Good. And k equals 1 and c equals 3. Think I'm right? Is that what you got? Let's go check it out. K equals 1. Very good. 1, 1, 4, 4, 1, 7. And c equals 3. So they actually asked for, that says, find the exponential model. So we're going to have to plug this stuff back in. Okay, so when we plug this back in, what we're going to do is what? Y equals 1 times 2 to the x plus 3. Now what's 1 times anything? Itself. So we can just write this as y equals 2 to the x plus 3. That's it. That's how easy that problem is. Okay. All right, the second part. What was this? This is number 11 still? Oh, B. That was A. Okay, 11 has a couple parts. We're almost done. 2 more parts for left. All right, find the exponential model of this one now. All basically the same thing. Just so you guys know, that point is negative 113. Got knocked off my page for some reason. I'll move it back on now. Okay, it's all better now. All right, so the way this works, substituting in negative 1, 3 gives you your answer, right? 3 equals k times 3 to the negative 1 plus c. So 3 to the negative 1 is 1/3. So 3 equals 1/3 k plus c. Substituting in 1 negative 13 into the equation, that's what this should be. 1 negative 13 just got cut off. Into the equation, what that gives you is something a little bit different. That gives you negative 13 equals k times 3 to the first power plus c. Now 3 to the first power is just 3. And what you end up with there is 3k plus c equals negative 13, or negative 13 equals 3k plus c. You could write it either way, it doesn't matter. Right? Now what we're going to do is we're going to take both those bits of information, and we're going to take those informations and plug them into the equation. So once again, I'll do it with you, because I just think it helps you guys out. I got my calculator on, I'm hitting main again, simultaneous equation solving next. All right, so I got my stuff right here. Oh, I just knocked that out of whack. All right, so we got this, let me just touch this. Oops. All right, I'm gonna have to reorganize this afterwards. My phone is falling down. Okay, so I got 1/3, this is why I want to do this. 1/3 is 1 divided by 3. So actually type in 1 divided by 3, hit enter, plus 1 equals 3. So I did 1 divided by 3 to get 1/3. All right, this one's a 1. All right. And then it's a 3k. So, oops, sorry, it's 3 plus 1 equals negative 13. Okay, so notice I got 0.33, that blah, 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 blah. 1 and 3, and then I got 3, 1, and negative 13. I hit solve, and I get x equals negative 6 and y equals 5. Okay, x equals negative 6 and y equals 5. Let me get this all set up again. Perfect. All right, so k equals negative 6, c equals 5. All right, so that right there, I'm able to use that information now to solve my equation. I take the k, plug it in, y equals negative 6 times 3 to the x plus 5. Negative 6 times 3 is negative 18, right? No, you cannot multiply these two because this piece is being raised to a power. So this is actually your final answer. Y equals negative 6 times 3 to the x plus 5. And then you're done. You're done, 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 done. All right, don't go any further, because if you go any further, your answer will be incorrect. Okay. Next one. Problem 11. Here we go. First thing, you're going to take your set up your equations. The first point I'm going to use, notice there is no intercept here, which is okay. I'm going to use point negative 2, 9. 9 equals k times 2 to the negative negative 2 plus c. 2 to the negative 2 is 2 squared. 9 equals 2 squared is 4. 4k plus c. Negative 5 equals, so we're using 1, negative 5. Negative 5 equals k times 2 to the negative 1 plus c. So 2 to the negative 1 is 1/2. 5 equals 1/2 k plus c. All right. Now we're going to take these two bits of information and we're going to plug them into our calculator. All right, so got my calculator here. Let me get a nice little zoom in. Good. All right, I'm going to go back to main. Simultaneous equation solver. Next. All right, what am I going to type in here? So I got 4k plus c. That's 4k plus c equals 9. Next one is 1/2 k. So 1 divided by 2. 0.5 plus c equals negative 5. Make sure you don't put in negative, not a minus. And I graph. I get 4, negative 7. All right, so let's go check to see if my answer is right. Plug all that stuff into my calculator. 4, negative 7 is indeed correct. Y equals 4 times 2 to the negative x plus a negative 7. Only difference here is this stays like this. Instead of putting plus minus, just make it 4 times 2 to the negative x minus 7. All right, now we're done. We're done with problem 11. 2 more problems. 2 more problems with 2 parts each. Doesn't sound too bad, right? Problem 12. The graph of k times 4 to the x plus c is shown. Explain here why k must be positive. Okay? Explain why c must be negative. And then we're going to do what we just did in the last couple of equations to solve. All right? So, the reason k must be positive is what is going on with our graph? Our graph is doing what? It's doing something here. The graph is increasing. Because the graph is increasing, k must be positive. If the graph was decreasing, k would be negative. Now, why must c here be negative? Our horizontal asymptote. Well, look at our horizontal asymptote's where? Under the x-axis. It lies beneath the x-axis. Anytime it's beneath the x-axis, c is negative. Anytime it's above the x-axis, c is positive. If it is the x-axis, c is equal to 0. All right? Now, find that exponential function. Go. All right, so you should be typing it into your calculator. Let me do it with you. I did every other one, might as well keep going, right? Whoop, ba-da-dum. Da-da-da-da. Main, 2, 2, 2, 2, 2, good. All right, let's see what we got. Oh, I didn't create my system of equations yet. I'm jumping the gun. So first I got to create my equations. So, what do we got? We use 1, negative 4. So we got negative 4 equals k times 4 to the first power plus c. All right. 4 to the first power is 4. Negative 4 equals 4k plus c. That's our first equation. Next one, we're going to use point 2, negative 2. 2, 2. 2 equals k times 4 squared plus c. 4 squared is 16. 2 equals 16k plus c. All right. So now we got our 2 equations. Now I can go to my equation solver. All right. So I got 4. Look at 4, 1, negative 4. See how quick this is? 16, 1, 2. Whoops. Get in there. Solve. 1/2. Negative 6. If you like fractions better, you can hit this button. 1/2 negative 6. 0.5 negative 6. Both are acceptable answers. K equals 1/2. C equals negative 6. So to find the equation, plug it back in. y equals 1/2 times 4 to the x plus -6. Make that a -6. 1/2 times 4 to the x minus 6. Pretty simple stuff. Right, now what you can do is, the next thing it asks, find the y-intercept. How are we going to find the y-intercept? Is there a way to find the y-intercept? How do you find it? Well, it's the y-intercept when x equals 0. So plug in 0. So y equals 1/2 times 4 to the 0 minus 6. 4 to the 0 is what? 1. Y equals 1/2 times 1 minus 6, right? Y equals 1/2 minus 6. Y equals -5/2. So what's my y-intercept? Y equals -1/2. The y-intercept is -11/2, -5/2. Okay. Next one, state the horizontal asymptote. This can be found pretty easily. How do you find that? What do you do? Let's see. Let's see. Horizontal asymptote. Y equals -6. It's whatever C is. Right? That's it. That is you. Ready for 13? Alright. So, 13. Go. Exponential function in the form f of x equals k times a to the x plus c has the y-intercept of 10, horizontal asymptote of y equals 2, and passes through point 5, 258. Find the exponential function. So, use all this information to find out what the function is. I am going to give you a hint. You're going to use, first thing, write down what the horizontal asymptote is. It is 2, right? So since it's 2, what can we figure out right away? We have to find out k, a, and x. We can find out c. So c equals 2. That was pretty easy. We got 2 right away. Now, next we're going to use the y-intercept. Y-intercept is 10. So what does that mean? That means when what is what is what? That means f of 0 equals 10, right? When x is 0, y is 10. So let's type this in. We got, so far, we got this. Let's type this out. F of x equals k times a to the x plus, so we got c so far, which is 2, right? So we got one of the 3. So k times a to the 0 power plus 2, because we got 2 right now, equals 10. Subtract 2 from both sides. K times a to the 0. Well, a to the 0 is the same as what? 1, right? So k times 1 is k, plus 2 equals 10. Subtract 2 from both sides, and k equals 8. Look at that. We got 2 pieces. Last piece we need is the a. And remember, we only need 1 point if we only need 1 equation. So we're going to take this, put it in there. So the graph passes through point 5, 258. So this is our f of x. This is our x. 258 equals 258. F of x equals 8 times a, which we don't know, to the 5th, right, plus 2. All right. Subtract 2 from both sides. 8 times a to the 5th equals 256. Divide by 8. So we subtracted 2 from both sides. We divided both sides by 8. A to the 5th equals 32. Take the 5th root I already know the answer to this. A equals 2. F of x equals 8 times 2 to the x plus 2. That was pretty neat, wasn't it? Look at that. Wasn't that easy? We're not done. We're not even done with this problem. Oh, you're done. Why do you do the same problem twice? Is that the same thing? Oh, new problem. I guess this is big. First one was A, this is big. So now we've got 13. An exponential function. Oh, this is actually 14. It says 13, it should be 14. In the form y equals k to the, now in this case, look at different. Negative x plus c. Y-intercepts 1, horizontal asymptotes y equals 4, passes through 1, 2. Find the information. All right? This is actually 14. All right? So, first thing, horizontal asymptote, y equals 4. That gives us something, right? That tells us c equals 4. So, f of x equals k times a to the negative x plus c. We got our 4. All right, next thing, we're going to use, so we use this up, we're going to use our y-intercept. So y-intercept is -1, so f of 0 equals 1. Okay, what that means is when x is 0, y is 1. K times a to the -0, or 0, doesn't matter, plus 4 equals 1. Okay, a to the -0 is 1. All right, plus 4 equals 1, so this just becomes k times 1 plus 4 equals 1. Subtract 4 from both sides, and k equals -3. All right, this is like multiplication. I'm going to put a little dot so you don't get confused with x. All right, so we got our -3. We're going to use our point, 1, 2 that it passes through. All right. So that means f of x, when x is 1, f of x equals 2. So we're going to plug in 2. We're going to go -3 times a to the -1 plus 4 equals 2. Subtract 4 from both, actually we can do this. 3 times a to the -1 is -3 over a. And then we subtract 4 at the same time, and you get -2. Okay, just remember, a to the -1 is 1 over a. So 1 over a times -3 is -3 over a. Now in order to solve for a here, I'm going to multiply both sides by a. Cancel out this a's. Leave a -2a over here. Divide both sides by -2. Leaving me with a equals 3/2. So, the exponential function, therefore, must be f of x equals -3 times 3/2 to the x, negative x power, sorry, plus 4. Okay. That's all there is to it. Any questions? Well, guess what? We're going to have a quick little discussion, very quick, and then we're done. All right, with the discussion, for an exponential function, a to the x, all right, what this says is a is not equal to 0. So what exactly does that mean? It says for an exponential function, y equals a to the x. Why do we choose to specify a can't be 1? But what happens if a is 1 here? What's 1 to any power? Well, 1 to any power is 1. So if we have this y equals 1 to any, it's just y equals 1, right? Y equals 1, for anything that's x, so that's just not exponential. Y equals 1 is just a what? It's just a horizontal asymptote. That's why it can't. Alright, B. Why can't a be greater than 0? Or why is a greater than 0 and a is never negative? What do you think? That's easy as well. If a is 0, right, y equals 0 for all x. So if a is 0, whatever x is, y is 0. And what's y equals 0? Well, then y would be a horizontal asymptote. If a is negative, y would be positive for all the even x's and odd for all the odd x's, meaning your graph would jump all over. Okay, it wouldn't be a continuous graph, so it couldn't be continuous. All right? So that actually has two reasons. And the last one, what does the graph y equals negative 2 to the x look like? What's its domain and range? You guys can sketch that real quick, check your answers, and then we'll discuss it. It's not really going to get into it right now. Okay. If you want to negative 2 to the x, we can just go right here. Y equals, now notice right here, negative 2 is in parentheses. Very important, negative 2 to the x. Let me just remove all this stuff real quick. You would enter, and look at it. Look what negative 2 to the x looks like. It's actually a double graph, which we really can't use. That's why the inside's never negative. Because when you raise this to a power, negative 2 squared is 4, right? All right? So depending on what you're raising this to, it's going to pretty much mess everything up. Got it? So negative 2 squared is 4, or negative 2 can also be negative 4. See that cool graph? It looks like it actually like splits open. Okay? All right. Anyway, we'll discuss that in class. Today, long enough lesson for me. We graphed exponential functions. We figured out where the asymptotes were. We figured out where the y-intercepts were. We figured out how to use the calculator and the systems of equations to actually figure out what the exponential equations were. And we had a pretty good day overall. It was a long lesson, yes. We spent a lot of time on it, virtually at least. And then hopefully, if you have any questions, you'll ask. And until the next lesson, take care.